This is a video of me going over the 12.1 through 12.3 quiz review. It says use the following information to answer questions 1 through 4. A bag contains 7 tiles lettered ALGEBRA. You randomly choose a tile from the bag. Find the probability of A or G. Are these events mutually exclusive or inclusive? Well, there's no overlap in pulling an A or a G, so these are going to be mutually exclusive events. So that we can go ahead and circle and say that that's true. I'm going to go ahead and write this probability. So this is the probability of A or, and we got that U for the or, G. So I want to write it the way that you guys might see it. So we want to go ahead then and find how many A's there are. And I notice that there's an A here and an A here. So that's going to be 2 over the total number of letters, which is 7. And then it asked me for a G, and I've only got one G here. So we're going to add 2 sevenths to 1 seventh. Again, we have a common denominator, so we're just going to add across the top 2 plus 1, which is 3 sevenths. Number 2 says you randomly choose a tile from the bag. What is the probability you choose an E or a vowel? Are these events mutually exclusive or inclusive? Now, these events are going to be inclusive because E is a vowel. So I'm going to circle inclusive here. So again, we're going to write the probability of an E with or a vowel. So that's our probability, E or a vowel. So the probability of an E, let's go ahead and erase this up here. We only have one E, so that's 1 seventh. And then we're going to add to it the probability of a vowel. So we have A, E, and A. So there's 3 of those. So we're going to add 3 sevenths. Now, the problem here is we have the E represented in both of those groups. So we need to subtract it because we can only represent it once. Otherwise, it's overrepresented. So 1 plus 3 is 4. 4 minus 1 is 3. So our answer is going to be 3 sevenths. The probability of getting an E or a vowel is 3 sevenths. Number 3 says you randomly choose a tile from the bag, replace it, then choose another tile. What is the probability of choosing a B then a consonant? Are these events independent or dependent? So on this one, again, let's write our probability. So our probability this time is going to be an and statement. So we got the probability of B and a consonant. Probability of B and a consonant. So B is a consonant, but it says that we're replacing it. So on this one, if it says independent, dependent, then we know for sure that this is an and statement and we're going to multiply. So we're not really worried about the overlap here. So this one is going to be independent, okay? So, because when we pull it, we replace it. Y'all notice this replace it right here? So that's really our key word in this phrase, or in this problem. So, the probability of us pulling a B, pretty sure there's only one of those. Yep, right here, the B. So that's going to be 1 seventh, and then we're going to multiply that times our probability of pulling a consonant. Well, B is one of our consonants, yes, but we've got some other ones, L, E, and A. So this one's going to be 4 sevenths. So when we multiply 1 seventh times 4 sevenths, we multiply across the top and across the bottom. So 1 times 4 is 4, and 7 times 7 is 49. So our probability of getting a B and a consonant is 4 over 49. Number 4 says you randomly choose a tile from the bag and do not replace it. Then randomly choose a second tile. What is the probability you choose an L, then a vowel? Are these events independent or dependent? Well, again, it says that we do not replace it, so this is going to be a dependent event because what we do second was affected by what we did first. So what is the probability you choose an L? So algebra, I'm going to write it up here, A, L, G, E, B, oops, sorry, B, R, A. So we only have one L, so that's going to be 1 seventh. And then what's the probability that we, if we don't replace it, we pull a vowel. So let's look at our vowels. We got an A here, an E here, and an A here. Now, the challenge is, or what we need to remember, is that we didn't replace it. So we don't have 7 left in the bag anymore. We only have 6. So this is going to be multiplied by 3 over 6 because we took out that L and we didn't put it back. So here we're going to multiply 1/7 times 3, 6. So we multiply the 1 times the 3, that's 3. And the 7 times the 6, that's 42. And remember, anytime we do these, you want to go ahead and check and see if you can reduce this. And when you can, it is 1 over 1/14. So it's 1/14, sorry. So number 5 says, what is the sample space for tossing a coin 3 times? So here we're going to have to look at what happens every time we toss it. So if we toss the coin 3 times, we could get heads, heads, heads. Then we could get heads, tails, heads. Then we could get heads, tails, tails. Now, if I start changing the first one now, then we could get tails, heads, tails. We could get tails, heads, heads. Let's see what else I got. Then if we put 2 T's at the front, then we could get tails, tails, heads. And we could get tails, tails, tails. So let's see how many that is. I think that should be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I think there's one I forgot. Let's see, what did I forget? Heads, heads, tails. Oh, that's the one I don't have. Heads, heads, tails I don't have. So when you do this, just make sure you have every combination of the 3. So you could get heads, and then the other 2 combinations, and tails, and the other 2 combinations, and then if I have heads, heads, what is the 3rd combination? So yeah, that's all of them. Then it says for number 6, what is the sample space for rolling a dice? Well, this one's a little easier. We know that it's 1, 2, 3, 4, 5, and 6. So those are our sample spaces. So basically, what are our potential outcomes when we do what they're asking us to do? So the next set of problems says you draw a card from a bag that contains 4 yellow cards numbered 1 through 4 and 4 blue cards numbered 1 through 4. Tell whether the events A and B are mutually exclusive or inclusive, and then find the probability of A or B. So event A says you choose a yellow card. So that's what we're going to look at first. And event B says you choose a blue card. So if we choose a yellow card, the question is, does it affect the blue card? So this one, I would say, is mutually exclusive, because if I pull a yellow card, it doesn't affect the blue card. So this is mutually exclusive, because when I pull these separate cards, one doesn't affect the other. So we got 4 8s here plus 4 8s here because we had 4 of each. So again, this is 8 over 8. So that's going to be 100%. Number 8 says you choose a blue card and you choose a number 3 card. Now this one's a little different. So this one's actually going to be inclusive because we have a blue card that has a number 3 on it. So I'm going to put IN here, INC, okay? That's inclusive. So again, when we choose the blue card, we have 4 8s, right? There are 2 number 3 cards because we have a yellow number 3 and a blue number 3. So we're going to say 2 over 8. Now, the deal here is, though, we have a blue card that is a number 3. So we have to subtract that. That's our overlap. Remember, any place where something's in both groups, we have to subtract that. So 4 plus 2 is 6, minus 1 is 5. So our answer here is 5 over 8. So with number 9, it says to whether events A and B are dependent or independent, find the probability of A and B. So, didn't completely erase my stuff there. So this one says a bag contains 3 red balls, 4 green balls. So the total number of balls was 7, so we got to find that because we're going to need that. You randomly draw 1 ball, replace it, and randomly draw a second ball. So if we replace it, this is going to be independent. So that was the first question we got to say, are they independent or not? So the first ball is red. So we had 3 out of 7 red balls. And again, this is an and statement, so we're going to multiply. So 3 over 7 times, and how many? Then it says the second ball is also red, so we're going to multiply that by 3 over 7 as well. So 3 times 3 is 9, and 7 times 7 is 49. So our answer here is 9 over 49. Number 10 says, you write the letters of the word brightness on a piece of paper and place them in a bag. You randomly draw one letter, replace it, and then randomly draw a second. So again, we got this important phrase right here, replace it. So it says the first letter is a B. So when we pull that, well, when we replace it, first of all, because we replace it, this one is also independent because we replaced it. So let's write independent first. So we know that what we do first is not affecting what we do second. So the first letter is a B, and I see that we have one B. So we're going to do 1 over 10. And then the second letter is an H, and we only have one H. So again, we're going to multiply that by 1 over 10 as well. So that's 1 times 1, which is 1, and 10 times 10, which is 100. So our answer here for what's the probability that we get a B and a B and an H is 1/10 times 1/10, which is 1/100th. Number 11 says the students in your English class are broken up into 4 groups of 4. Each group is assigned a project, and the groups will present the results of the project on Wednesday, Thursday, and Friday of the following week. In each group, one person will be chosen to present the results. What is the probability that your group will present your results next Thursday and you will be chosen as the presenter? So when we read this problem, we need to think through what they're saying. First of all, it says that the English class is broken up into 4 groups. Each group is assigned a project, and we're going to then present our projects on Wednesday, Thursday, or Friday. So the day of the week that we're going to represent is one of the 3 days of the week. That would be Thursday. And again, this is an and statement. What is the probability that your group will present the results next Thursday and you will be chosen as the presenter? So Thursday is a 1 in 3 chance, and then that I'm the presenter is 1 in 4. So we're going to multiply that again because it's an and statement. So we multiply across top. 1 times 1, which is 1. 3 times 4, which is 12. So there's a 1/12 of the chance that I'm going to be the presenter on next Thursday. So the next set of problems says, using a standard deck of cards, find the following probabilities when picking only one card at a time. So this U means or, so or means we're going to add. So we've got 4 over 52 because there's 4 6s in the deck, and there's also 4 queens in the deck. So that's 4 plus 4 over 52. That's going to give us 8 over 52, and that can be reduced to 2 over 13. And remember, you always want to reduce your numbers. Okay, so the next one is a red or a black. So again, the probability of us getting a red is 26 over 52. And we're going to add to it, again, this is our or statement, blacks, which are 26 over 52. So that's 52 over 52, which means we have a 100% chance of getting red or black. I think we all knew that. Okay, so our next one is face or king. So there are 12 face cards in a deck. Face cards are king, queens, or jacks. And because we have 3 of those and 4 suits, it's 3 times 4, which is 12. And then it says, or a king. So on this one, we need to think about this one a little bit because there is a face card that's a king. So a king is a face card, basically. So we have 4 kings. So we do have some overlap here. So one of our faces, not one of our faces, but 4 of our face cards are kings. So we're going to subtract those 4 because they're represented twice. They're represented in our face cards here, and they're also represented there. So that's actually just going to give us 12 over 52. Now, if we reduce that, that gives us 3 over 13. That was our final answer. So number 5, this is a prime. So if you see it with this little c next to it, or it has p prime next to it, then we're going to actually, this is the probability that we did not choose a 4. So we want to go 1 minus 4. There's 4 4s in a deck of cards. So 1 minus 4 over 52. Now the way I like to do this is make this 52 over 52. And then subtract the 4, because 1 is the same as 52 over 52. So when I do that, I get 48 over 52. And then we're going to reduce that. And when we reduce it, it's going to be 12 over 13. And if you guys recall on your calculator, if you just divide 48 by 52, push math in 1, then it will reduce it for you. So next we have number 16, 17, and 18. So it says you draw one card, keep it, and draw another. So this keep it right here tells me that this is going to be a dependent event. And I know it's going to be dependent because we have an and sign. So that upside down, or I will just call it, it looks like an N to me. So let's use and here. So the first one says red. So how many red do we have in the deck? We have 26 out of 52. And then if I keep that card, I don't have 52 cards left, but I do still have 26 black cards. So I'm going to multiply that by 26 over 51. Now when I do that, I get 676 over 2652. And when I reduce that, that is 13 over 51. Number 17 says a spade and an 8. So again, there are 13 spades in my deck. So 13 over 52. Again, going to multiply because it's an and statement. And how many 8s do we have in the deck? We have 4 8s. However, we have an 8 of spades, right? So we can't say, because we might have pulled that 8 of spades on the first one, that we can include it. So we have to multiply this times 13 over 51. So when we do that, we get 39 over 2652. And again, that reduces to be 1 over 68. Number 18 says the probability of a queen and an ace. So on this one, again, we have 4 queens in the deck. So that's 4 over 52. Again, we're multiplying because it's an and statement. And we have 4 aces in the deck. Again, we took one out. We didn't put it back. So this is going to be 4 over 51. We're going to multiply across the top and across the bottom. When we do that, we get 16 over 2652. And when we simplify that, we get 4 over 663. So number 19, it says in a survey, 30 students were asked to pick 1 or 2 of their favorite colors from a list of 3. Use the Venn diagram to answer the following questions if a student is chosen at random. It says, what combination of colors were not chosen by any student? So obviously we can see that orange and blue were chosen and blue and pink were chosen, but there is no overlap of the orange and pink. So the combination of colors that was not chosen by any student is orange and pink. Okay, this next question, it says find the probability of orange or blue. So I'm going to write this like this, probability of orange or blue, just because I want to make sure y'all are getting in the habit of doing that. Okay, so this is our or, so that means we're going to add the two probabilities, probability of orange plus the probability of blue, and then we're going to subtract the overlap, okay? So the probability of the orange, so we've got 6 plus 5 here. I'm going to go ahead and write that 6 plus 5 over our total, which up here says is 30, right? Then we're going to add to that our blue, which would be 5 plus 12 plus 2. And we are going to put that over 30 as well. And then we're going to subtract the overlap. Well, the overlap is right here. It's that 5. So we're going to subtract the 5 over 30. Okay? So I'm going to go ahead and write this out now. This is going to be 11 over 30 plus, that's going to be 19 over 30. And then we're going to subtract from that the 5 over 30, right? So that's going to be
30 minus 5, that's going to be 25 over 30, which can be reduced to 5 over 6. And 5 over 6 is 83.3%. So this would be equal to 0.8333, which is 83.3%. Okay? Now this next part says, find the probability that it's blue and pink. Now this is this and statement, so this is going to be the probability of blue and pink. Now if you remember, this is when we're going to multiply, right? That's what it tells us on our formula sheet. So we're talking about blue here and pink there, right? Well, this is an and statement, so what are we really looking for? We're just looking for that overlap right there. Y'all see that? So this one's pretty easy because I can just put that 2 over the 30, which reduces to be 1 over 15. And 1 divided by 15 is 0.0666, right? So that is 6.7%. Okay?
So our last problem says draw a Venn diagram for the situation. Well, I'm not just going to draw a Venn diagram. I'm actually going to solve for a probability too. But so it says, up 300 surveyed, 98 people voted to change the school colors. 63 voted to change the school colors and the mascot, and 76 voted to change the school mascot. So what I notice is our two distinct things here are colors and mascot. So I'm going to write colors here, and I'm going to write mascot here. Okay, so it says that 98 people voted to change the school colors. So I'm going to put the 98 up here. 63 voted to change the school colors and the mascot. So that number actually goes right here. And 76 voted to change the school mascot only. So that, or not only, but just the school mascot. So now if we wanted to find the people that chose colors only and the people that chose mascot only, then we need to do some subtraction here. So we need to subtract 63 from 76 over here to figure out how many people, and that's 13. So that's how many people chose the mascot only. Over here, we would do a similar process, 98 minus 63. And when we do that, we get 33. So this would be our Venn diagram. And if we wanted to find out how many people were outside of this whole thing that didn't choose either, that were surveyed, we could add up the three numbers and find out how many people didn't choose any of them. Okay? So, but if you were to ask me, what's the probability that someone chose the mascot? Sorry, see, can't write today. Or the colors. What we're going to do is we're going to do our 96 over 300. We're going to add to it. Those were the people that chose the colors. And then we had the mascot people. That's 76 over 300. And then we're going to subtract our overlap. That's that 63 over 300. Now we do that and we put it in, so we get 109 over 300, and we're always going to put this in a percentage. So this is going to end up being 36.3%. And again, the question didn't ask us to solve it, but I think the more practice we get, the better we get.